This is lesson 1.3. It's on the back of what, page 2 or 3? Just page 2? All right. We're going to talk arithmetic sequences, and we're going to go fairly fast because we already did a whole day on arithmetic sequences, or actually a day and a half, right? Explicit form means that you are, that's the harder one to me. The recursive form means we're just adding a difference. That's the definition. It is a sequence with a constant difference between terms. Okay? The explicit form is the one that was kind of weird to us. It said to find some term, you take the first term and add that difference n minus 1 times. And why is it n minus 1? So if you want to find the 52nd term, you only need to add how many differences? 51, and you're adding it on to the first term, which is where that comes into play. So that's all review for us. Let's see what we can do with this one. We have 2, 5, 8, 11 is an arithmetic sequence with a constant difference of 3. If u sub n is an arithmetic sequence with, oh, that was an example, I think. That didn't have anything to do with this question. I'm sorry. All right, question 5 starts here. If u sub n is an arithmetic sequence with u sub 1 equal to 6 and u sub 2 equal to 8.1, the only way we can do this problem is if we know what kind of sequence it is. Because we could have gone a lot of complicated ways to get from 6 to 8.1, right? There's a whole bunch of funky things we could have done that would have got us those same 2 points. We could have done some cubic thing or something. But if we're told it's arithmetic, then we know that the difference was what? Can we figure that out? 8.1 minus 6. The difference between any two successive terms should be 2.1. So that's the answer to A. B says write the sequence as a recursive function. What two things do you have to tell me when you write recursive? U sub 1 is 6. I know it's already up there, but you still have to, it's part of the recursive form. And then you say u sub n is? The previous term, u sub n minus 1. And what are we doing to this guy? Adding 2.1. All right, give the first 7 terms of the sequence. What's the first term? What's the second term? 8.1. The next term would be 2.1 more than that, which would be 10.2, and then yeah, I skipped one, didn't I? Control Z. 12.3, 14.4. Am I on the right track now? All right, you guys can keep going. That's enough terms for me. Graph the first 7 terms. How does this go again? Can anybody remind me from yesterday? What goes across the bottom? The term number. So term 1, term 2, term 3, term 4, term 5. You don't have to do 7 terms to make me happy. I just want to know that you're getting the right shape and everything, okay? What's the first value? Oh, okay, so I shouldn't count by ones, or I should make my little lines closer together. 1, 2, 3, 4, 5, 6 is term 1. And 7, 8, term 2 is 8.1. 9, 10, a little bit above that should be term 3. The bottom line is it should be looking like what? A line. Okay, that's going up by 2.1 every time. The slope is actually what? 2.1 over 1, because it's going, every term number 1 is going over 2.1. All right, we happy with that question? Easy peasy? Okay, this next part, there's 2 ways to do this question. One way that I will accept is not really a fancy pre-calculus way. You would just generate the terms and show me. So put in n equals 1, 2, 3, 4, and show me that it's arithmetic and find its difference. So let's do that really fast. If I put in a 1, what do I get? -2. If I put in a 2, I get 6 plus -5 is 1. If I put in a 3, 3 times 3 is 9 plus negative 5, anybody? 4, one more time, if I put in a 4, get 12 plus negative 5 is? Okay. Is it arithmetic? Yes, it's arithmetic. We showed it by coming up with some terms where the common difference is it's always going up by 3. Okay. The fancy pre-calc way to do this is to show that taking the current definition and subtracting the sequence where you've put in the previous term, n minus 1, should come up with previous term, one term minus the previous term. Previous term. Do I have these backwards? You would normally take term 5 and subtract term 4, right? Yeah. I think I have it right. Okay, let's try this. So you're taking the sequence of the formula they gave you, subtracting if it was the previous term. So you've put an n minus 1 in here. Okay, do the algebra for me, guys. Negative 5 plus 3, and minus a negative 5 would be plus 5. And back here, if I distribute, this becomes 3n minus 3, and now I have this negative out here, so it's going to become a negative 3n and a plus 3. Have I totally lost anybody with the algebra?
Yeah, 3.
And this cancels, and I have 3. So this is your common difference. Okay? I am perfectly okay with this, because this shows me that you understand what's going on. You've generated this sequence and you've shown me that you see it's arithmetic and you've given me the difference, okay? I will accept this if you want to do this fancy dancy way. Yes?
How does that prove anything? Because you can just look at the thing and know that it's the common difference is 3. It says it right in the explicit formula.
Yes.
So what does that prove? Like, is there a way
It says show. It's not really a proof, it's a show. You've shown it by generating the sequence or showing that it's a difference, okay?
Yeah.
Number 7, show that it's arithmetic and find its common difference. So I'm going to put in n equals 1, 2, 3, 4. Hopefully that'll be enough. If I put in a 1, if I put in a 2, if I put in a 3, I'm just kind of writing down a little bit of the steps so that I can think about this. Put in a 4. Okay, I got 12 thirds, which reduces to 4. Then I got 16 thirds, which doesn't reduce, right? Then I got 20 thirds, which doesn't reduce. But then I got 24 thirds, which does reduce. So if I just had written this down, it wouldn't have looked very arithmetic to me. But when I wrote it this way, 12 thirds, 16 thirds, 20 thirds, 24 thirds, can you tell what's the difference there? Okay. Again, because it's pre-calc, I'm going to show you the long, ugly way. Okay. This one is just 8 thirds plus 4 thirds, and I just divided them both by 3. This one I'm going to leave minus parenthesis 8 plus and distribute. That's all over 3. What does that simplify to, guys? 8 plus 4n minus 4 simplifies to 4 plus 4n. Everybody with me? 8 minus 4 is 4. And now these are thirds, but there's a minus out here. So I end up with 8 thirds plus 4 thirds and minus this, which is 4 thirds minus 4 thirds, and when I distribute the negative and put the 3 underneath both, what happens? I get, okay, don't have to do that. But it's going to ask you to do this on your homework, and you need to show me one way or the other, okay? All right, for the arithmetic sequence that has a third term of 13 and a common difference of 3, find u sub 6. Okay, help me out. What do we need to do? If the difference is 3, the next term is 16, the next term is 19. The previous term before here was 10, and the previous term was 7. Okay, so what's term 6? 22. Okay, find the recursive form. To find the recursive form, we had to find what? The first term. We did. We said the first term is 7. Every term after that is the previous term plus 3. That's it. Okay, write an explicit form. What's the formula that's explicit? Okay, so fill that bad boy in. U sub n equals 7 plus 3 parenthesis n minus 1. Can you simplify that? I got 4 minus 3n. Did anybody else get 4 minus 3n? Or negative 3n plus 4? Did I do it right?
4 plus 3n.
Yeah, 4 plus 3n.
Oh yeah, I don't know where that minus came from. Just trying to trick you, see if you're awake. Or I'm just a mental midget. Are we okay? Alright. Now we have to talk about series. If we have a sequence, when we replace the commas with pluses, we're actually getting an arithmetic series. It is also, we use this summation notation, okay? This is called a summation symbol. Or a sigma, does that sound right to those of you who know your Greek letters? Okay. So it is sometimes necessary to find the sum of various terms in a sequence. For instance, we might want to find the sum of the first 9 terms in a certain sequence. They will tell you down here that they're going to start with term 1, up here that they want you to end with term 9. So this summation notation means you want to add up terms 1 through 9. Okay? That seemed pretty easy? That was right out of the book. Okay. We have a homework check to get through. This is a really fun example, but I'm going to go really fast, okay? It says in 3rd grade, Gauss discovered a way to add the integers from 1 to 100. Okay? He started writing them down. 96, 97, 98, 99, 100. He got an answer super fast. Can anybody figure out what he did? No, he didn't have a calculator in 17 something. Look what if you do the first one and the last one, guys. What do you get? 101. If you do 2 and 99, what do you get? If you do 3 and 98, what do you get? Now, if there's 100 terms, how many times is he going to have to add up 101? No. 50 times, because the first and the last one together made the 101, so there's only 50 combinations of that. So take 50 times 101. What is it? 5,050. All right, here's what he did. Again, he took going this way, and then he took it backwards, and he said, well, these add up to 101. So there's 100 terms. He actually thought about twice that would be 100, and then he divided by 2. So he got this. We're geniuses. Try the same technique for this. Okay, but you have to know how many terms there are in between there, right? So could we do that? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. How many terms is that altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms? So the first and the last one add up to how much? But if there's 10 terms, we're going to actually multiply by 5. Okay? What do you get? Okay? So the formula, it says these represent a finite series. A finite series is the sum of a finite sequence. In other words, it has an end. Do you see the formula for the series yet? Well, what did we do? Did we add the first and the last, and then we took how many terms divided by 2? Okay. It even works if there's an odd number of terms. If a college student borrowed $5,000 in loans, after graduation, the loan was repaid over a 100-month period. So how many payments did they make? 100. With monthly payments of 75, 74, 80, 74, 60, and so on, how much did the student pay? Well, do we know the first and last term? This ... it ends here. So let's figure out how much they paid. The first term was 75. The last term was 55.20. And how many months did they pay it? 100, but we have to do 100 over 2. So the sum of the first 100 terms, somebody type that in and figure out what we get. What is it? Did anybody else get that number? Okay. Does it make sense that if you borrowed 5,000 over, this is what? 5, 6 years? 7, 8 years? 8 years. Yeah, that you'd have to pay back $1,500 extra in interest, right? Okay. Unless you were me and you had to pay 9% interest. It was horrible back in the day. All right. This expression is the same. It's just written differently. What is this asking us to do? Find the sum of the first 6 terms. Could it be, there's going to be some of these that are not arithmetic or geometric. Is this one or the other? Well, how would we figure that out? Yeah, at least find a couple terms. If I put in a 1, what do I get, guys? 1. If I put in a 2, I get 3. If I put in a 3, I get 5. So could we generate the first 6 terms and add them up really fast and be done? 1, 3, 5, 7, 9, 11. There's 6 of them. 36, I think. Did I add up 6 terms? Okay. Yeah. Did some of you do it by doing 1 plus 11, 3 plus 9, 5 plus 7? Okay. The formula would say I'm adding 6 terms. The first term is 1, plus the last term is 11. So you would do 1 plus 11 is 12, times 3 is 36. All right? On your calculator, when you know the form, there is a way to do this. It's going to look like this. We're going to go to find the word sum, and I'll show you in 1 second. Sequence. The one we just did was what? Can I go back a slide here? 2n minus 1. Okay? So we're going to put 2n minus 1 here, comma, variable is n, comma, 1, comma, 6, because we wanted to add up the first 6 terms. Okay? Now, this, using the calculator is only halfway helpful because it's a lot of buttons to push, but it's really helpful if you wanted to only add up term like 10 through 57. Okay? Then it just does it blink of an eye and you didn't have to think about all that. All right. Calculator. Actually, if I go to the next slide, I might have, nope, I don't. All right. Anybody figured out? It's second stat, on helps, second stat, but this time you have to go over twice to the math, and there's the sum one. You find it? Okay, hit enter. You should have been in the home screen when you did that, Hofbauer. All right, in the home screen, second stat, arrow to the right, down to sum, enter, sequence. Where was sequence? We went by it once. Second stat, arrow to the right only once, and it's down to number 5. Now my mode, I get this. You guys, on the other hand, just get the word sequence on your home screen, right? Okay, I'm going to put in 2n minus 1 or X. It doesn't matter what variable, it doesn't matter what mode you're in, it will do it either way. I'm going to arrow down. Instead of arrowing down, you guys are all going to type a what? If you have the older operating system, you're going to put a comma. Then you have to put in the variable again. So hit the X or the N again. Then a comma or enter terms 1 through 6. And you do 1, 6. And then just hit enter several times and you should get it. Or once if you typed it all in. Did you get 36?
Yep.
Okay. What time are we out of here?
26.
Alright. Here's this. I'm hoping you have time to fill it out. Those of you who've never done a homework check, you need to copy the answers onto here that it asks for as quickly as you can. I did not ask you to show a lot of work, so it should be really quick to fill it in. And then you staple your papers. You have to turn in the homework assignment as well as this sheet. Okay, so if you've never done a homework test before, let me know and I can help you figure out what you need to do. Just be really careful that you're copying the right numbers on there. Still have 5 minutes. You should be able to fill it in if you did your homework.